let's now start. Let's now start the functions once again. In earlier classes, we have discussed what is a function. Let's revise for every. Do you have any doubts from previous class?
No, sir.
Okay, so let's revise. For every input, there should be a unique output in the codomain. Really, and we have also discussed about vertical line test and algebraic check. Domain, codomain of a function. Many one function is what one function, onto functions, into function, bijective function, and this is surjective function. This is this is injective function, and surjective function is the function which is onto and one both. Sorry, no, bijective function is the function which is injective and surjective both. Okay, so even and odd functions, there are some properties of even and odd functions. Is that the derivative of even function is an odd function, and the derivative of odd function is an even function. Let us say f of x is equals to x square. X square is odd function or even function? This is odd function or even function? Please respond.
I'm just thinking, sir.
Yeah. Try putting minus of x on the in the place of x, and if there is no like significant change in f of x, then it is an even function. Otherwise, this is written here definitions.
The even.
Yes. So this function is odd function. It's derivative. Is the example of this property. Here,
Yes, sir.
let's discuss methods to find one and many one function. So if there are two elements which are not equal, so their output must also not be equal. Then the function is one. If we have assumed the outcomes of two variables as equal, then their variables must be equal. And the function is one. Any function which increases monotonically, that is, its derivative. What are monotonically increasing functions? We discussed this in calculus. Monotonic means whether the f dash of x should be greater than 0, strictly increasing, or f dash of x should be less than 0. So basically, monotonically, this is a positive slope function, so slightly going upwards, not slightly, but going upwards, and the slope is negative here, so it will be decreasing, monotonically decreasing. So that's the case. If any one of the case is there, then the function is 1 1, then is a more 1 1 function. For example, this is for all x in domain means it should not be the case that we are discussing about a function, it is first monotonically increasing then decreasing. No, then it will be a uh, then it will be a many one function. Like, why? For two different values of x, the output is same. That's why this function is many one function. So it is you have to make sure that f dash of x is greater than 0 for all x in domain. Okay? For all x in domain, we have to, if we are discussing about this function, then this should be the domain for it to be many one function. Sorry, one more function. Clear?
Yes, sir.
And please do not think he, sir will get a problem and he will think, why I am not getting this. No, if you still have any doubt, You may ask n number of times. Okay.
Yes, sir.
Fourth point is any continuous function which has at least one local maxima or local minima is many-membered. So if there is any continuous function, if in its in interval it is having any local maxima or local minimum. So as we can clearly see for like this particular value of x1, this particular value of x2, this there is the same value of x1 and f of x2. There is same value of y here. So for two different values of x, there is same output. So the function is many one, and same goes for other function also. And what we are doing here, and earlier also, we are checking this function's graph. So if there is any line parallel to x-axis intersecting the graph in more than one point, where more than one point of intersection was there, then the function is manual, because on two different values of x, f of x, the value of function was coming as same. So if it is happening so, then the function is having many one, like for x1 and x2, there is the same output. So this is a many one function. Clear?
Yes, sir.
And talking about local maximum, local minimum, it means that this is the local maximum, this is the local minimum. So the function is going upwards, then coming downwards. So that's why I have drawn the curve like this. Clear?
Yes, sir.
Discussing point number 6. If we put okay, if we put f of x1 is equals to f of x2, since x of x1 is equals to x2, always satisfy f of x1 is equals to f of x2. So x1 minus x2 will be a factor of f of x1 minus f of x2. We're going to take an example to understand this. And let f of x be a one function, so 2x plus 3. Okay, yeah. So now, if we put f of x1 is equals to x2, since x1 is going to be x2, it always satisfies, okay, it's happening. So why? If we put f of x1 here, so it is 2x1 plus 3, put f of x2 here. So 2x2 plus 3, if we equate them, then 3 cancels 3, 2 cancels 2, and result is x1, x2. So this is a one-word function, simple. Okay, so x1 minus x2 will be a factor of f of x1 minus f of x2. Instead of doing all this, putting them equal, if we do, if we subtract both of these, f of xn minus f of x2, so 3 cancels 3, 2 is common, x1 minus x2. So yes, x1 minus x2 is a factor here. So x1 minus x2 will be a factor. Yes, it is a factor here. Why I'm calling this as a factor? Is that clear?
Yes, sir.
Because this is simply multiplying 2. So f of x1 minus x2 is the multiple of x1 minus x2. So this is the factor. And in other terms, when we write 4 as 2 into 2. So 2 is a factor of 4. Similarly, x1 minus x2 is a factor. Clear?
Yes, sir.
Okay. So hmm. Hence we can write as f of x1 minus x2. Now f of x1 minus x f of x2 can be written as, let's consider this 2 as a constant function of in terms of x1 and x2, and there is x1 minus x2 itself. So we can write this as where g of x1 x2 is just some function of x1 and x2. We consider this as a function, as a constant function in variables g1, g of x1 and x2. Now if this becomes 0, okay, uh, if this becomes 0, then and x1 is not equals to x2. Hence, f of x is minimal. Basically, it is trying to say that if we find f of x1 minus x2 and x1 minus x2 is not a factor there, and we are not able to factorize this from f of x1 minus x2, then the function f of x is minimal. Let's take one more example to understand this. What is a one function? Is x square a many-one function? If we put -1 and +1, the output is going to be the same one. So it is a one function. Clear?
Yes, sir.
Good. Now it's solved it. So f of x1 minus f of x2. So x1 square minus x2 square. So a square minus b square is what?
A plus B
Now,
minus B.
yeah. So this is a factor here. Okay. Now let's reread the definition. So hence we can write as this, where g of x1, x2 is some function. Now if g of x1, x2 becomes 0, okay. If this is becoming 0 and x1 is not equals to x2, hence f of x is manual. I'm still not able to commemorate. Let's leave this property, okay? And if you have to check whether a function is manual or not, simply go back to the definition of manual function and check. Simply do one thing. First of all, consider f many-one or one. If you have to decide in between these two, that whether a function is one or many-one, simply assume, put the value, substitute the value of x with x1 and x2, and then assume these two functions output as equal, and then solve and solve and solve. If x1 is coming to be as x2 as the only condition as the result of it, then we will call our function as one function. Otherwise, many-one function. Let's take an example with the previous function as well. As we know, f of x square is a many-one function, right? And f of x 2x plus 3 is a one function. Now let's try to solve and show how we'll be able to prove that. So considering this in both the cases. So this will become x1 square is equals to x2 square. This will become 2x1 plus 3 is equals to 2x2 plus 3. Now 3 will get cancelled easily. Now writing this on the left hand side, this becomes a identity a plus b into a of minus b is equals to 0. Now solving this, 2x1 is equals to 2 of x2. Now 2x1 minus 2x2. Whenever there is a variable, now do not cancel directly. Always remember this. Take 2 common here. Now 2 cannot be, when there is a multiple of 2 can only be 0 if m is 0 or n is 0 or both are zeros. Okay. So when we discuss about this particular equation, 2 cannot be 0. So x1 minus x2 has to be 0, and this shows that x1 is equals to x2, which means that if we consider f of x1 is equals to f of x2 and the result is coming like this, so this function is what? This function is what? One function or many-one function? If we were assuming that the output for two variables are same, and we have concluded the variables are also same, like for a single variable there is a single outcome. So what
Single
time?
variables or single output?
Yes.
Then one answer.
Okay, yes, great. So this is one function. Now here we are not able to clearly say. Here also there is one contingency in which this has to be equal, but there is only another condition in which this may also be true. So this is a many-one function. Understood?
Yes, sir.
Understood why we have written it so? Because action is x2 is one contingency, or if this is staying true, then it may also be equate. Okay, simple. Now let's discuss about this function. So this is very easy. Okay. First of all, checking about one or many one. So let's discuss colorful pens. Assuming f of x1 is equals to f of x2. So 2 of x1 is equals to 2 of x2. Bringing this on the left hand side, taking 2 common, x1 is equals to x2. Okay. So this is the only condition which has to be true, because 2 cannot be 0. That's why this has to be 0 to make right hand side the result as 0. Clear? Clear?
Yes, sir.
Yeah. Let's now discuss whether the function is onto or into. So for that we need to check well the codomain. If the codomain is equals to range, then the function is onto. What is codomain here? So let n be the set of all natural numbers. F of C. What is this? What is A here? What was A here? Domain, codomain, range. What was A here?
Is it domain, sir?
Yeah, it's domain. This is what?
Codomain.
Yes. So this is domain. This is codomain. Okay. And don't be so like hesitant while speaking. Just speak. If it's wrong, no problem. I'll correct. If it's correct, it's great. So let's now check the codomain is natural numbers. Okay. So the function is 2 of x. And domain means the value of x input. So they are all natural numbers, and range will be the output. So if we list all the natural numbers, that is 1, 2, 3, 4, 5, and goes on. So this is our uh, natural number set, and the codomain is also the set of natural numbers. So 1, 2, 3, 4, 5, 6, 7 goes on. And now let's map. Okay, using the function 2x. So for 1, if you put x as 1, so what will be the outcome? If x is 1, so what will be the outcome?
Uh, 2.
Yes. If 2 is the input, if 2 is x, what is the outcome?
4. 6.
Okay. So for no x, the output can be 1, right? For no value of x, the output can be 3.
Hmm.
Because our x, this is the set of natural numbers, not real numbers. If there was numbers like this, then also one will be mapped, but it is not the case, right? So these 1, 3, all the odd numbers will be left out. So here is our codomain equals to range. Is it the case? Codomain is the set of natural numbers, and range is the elements which are getting mapped in codomain. So are all the elements in codomain getting mapped? Think and answer. No. Is one getting mapped? Is 1 getting mapped? Is 3 is getting mapped to any element in the domain? Yarini, are you there?
Yes, sir.
Yeah. So is 1, 3, 5, 7, all the odd elements getting mapped to any number in the domain? That's domain. Uh, Simple. It's very simple. Only 2, 4, 6 are getting mapped to numbers. Now 4 will get mapped to 8. 5 will get mapped to 10. 1, 3, 5, 7, 9. These numbers are not getting mapped to any input. This is like set of x. This is f of x. Not f of x. The elements which are getting mapped only, right? 2, 4, 6. This is f of x. Okay. This is set of codomain. Clear?
Yes, sir.
So is the codomain equals to range here? This is my question.
No, sir.
No. Why no?
Mm, because there's not a domain for few codomains. Like
Yes.
3, 5 and all don't have no, so
And why don't they have any?
because they don't like obey the 2x function.
Yes. Very right. Very right. So here codomain is not equal to range. So if codomain is not equals to range, uh, is our function onto or into? It's into. Okay. It's into. So 1, 1 into should be our answer. But the given answer is incorrect. Should be 1, 1 and into only. C should be the correct answer. Okay.
Yes, sir.
Please revise the notes. Okay.
Sure,
Take
sir.
out some time. Let's discuss about inverse relation. When we were discussing about uh, when we were discussing about inverse relations, composition of relations. Okay. Then what we were discussing that if this is a set, if this S is a relation and set from A to B, and R is a relation from C to D, then B and C has to be. And same goes here also. If there is a function A to B, okay, if F is a function A to B and G is a function C to D, then for Z of F to exist, A to B and C to D, B set has to be equals to C. Means it means, and in other words here also as it is written that if where it is, anyway, leave. So do you able to relate that how we were, this is composition of relations, and now what we are discussing is composition of functions. Clear? Clear?
Yes, sir.
Me show. Here it is. So if there is a function like ZOF function will be defined when this is a function from A to B and G function is a function from B to C. These two sets has to be equal. Then only G of F will be defined. How it will be done so? First of all, we will map the F relation from A to B. Then we'll map the function from B to C, that is our G relation. and this is a relation, composition relation of G of F. Okay, that's how they have done so. Clear?
Yes, sir.
G of F is similar to writing G of F of X. It's like when we like there is a G of X equals to X square. So if we change the variable, it will look like this. So similarly, if we will change the variable to F of X, it will look like X. X will be substituted with F of X to look like this. So this is the composition function. It is equivalent to writing COF. Clear?
Yes, sir.
And if I further like add some another function there, let's say E, F, G, H. So H will be H, O, G of F. Okay. So let's
Yes,
take
sir.
some example. What is happening here? So this is a function 2x square plus 3 of x plus 1. And g of x is a function x plus 1. Okay. And we have to find out f of g of x and g of f of x. So it is similar to writing f of g of x. What is f of x? 2x square plus 3x plus 1. So on place of x, we will substitute x plus 1. X plus 1 whole square plus 3 into x plus 1 plus 1. So this is our f of g of x. Discussing about clear, any doubt?
No.
This is similar to writing g of f of x. So what was g of x? X plus 1. So in the place of x, we are going to replace it with the new variable, which is f of x. So 2x squared plus 3x plus 1. This is our x plus 1. Okay. So this is the g of of x. Okay. Clear?
I couldn't understand the G of X, sir.
Okay. It's confusing to narrate, not to solve. G of x. So it is similar to writing g of, well, instead of x, there is a new variable f of x. So g of x is x plus 1. So for writing g of f of x, we'll simply replace x with f of x. What is f of x? 2x square plus 3x plus 1 and plus 1. So this is our g of of x. Clear?
Yes, sir.
Clear? Out? Out. This is what?
No, no,
Painting.
no, sir.
Okay. G of x. The remaining is. So let's continue the discussion of the product of any function with the identity function itself is the function itself. What is the identity function? What is identity function? Here it is. Let a be a non-empty. Basically, when the output of the function is same as the input, simple. There's a function, we are given some input, and the output is also same, whatever the input was. If we have inputted 2, the output is also 2. If we have inputted A, the output is also A. If we have inputted C, the output is also C. If we inputted omega, the output is also omega. No change, okay? Understood?
Yes, sir.
Yeah, so this is our identity function. Any composite function is getting multiplied. Hmm. The product of any function is the identity function is the function itself. The product of any invertible function with its inverse function is an identity function. It's similar to saying that if we do multiply 2 with 2's inverse, so what is left is identity unit. So if we multiply any function with its inverse function, if it exists, inverse function, then the what is left is identity function. Clear?
Yes, sir.
Yeah. Composite of functions is associative. I've just described that here. Mm, Where I was saying that writing h of g of x similar to h of g of f of x. This is associativity. And more we can learn here simply a plus b plus c can be written as a plus b plus c. So f of g of x, f of g of h can be written as f of g of h or f of g of h of x. Understood?
Yes, sir.
Yeah. Let a function a to b and g be a function from b to a, and g of gof is an identity function on a, and f of g is an identity function on b. How so? Let's understand. Yeah. Also, let's understand if f, we are discussing first, let's discuss fork. So G is a set from B to A, G is a relation from B to A, and F is a relation or a function from A to B. So this has to be same. Okay. Mhm. So now this function will be left on B to B only. Okay. And if we discuss about Coke, is it correct? Coke is an identity function from B. Yes. If we discuss about fork, it was B to B and B to A. This has to be equal to left with A to A. So both will be a function on A to A. Okay. So as we are saying that this f is a function from A to B, so similarly you will say gof is a function from A to A, and fo is a function from B to B. Given that f was a function from A to B, and g was a function from B to A. Clear? Any doubt?
Clear, sir.
Any doubt? Hmm. Let f is a function from A to B, g is a function from B to C. Is a one onto function. Okay, one onto function. Uh, Let me simply shortly tell you about invertible function. Invertibility is a function whose inverse exists. And for a function being able to possess or exist as inverse also, the function has to be 1 and onto. If a function is 1 and onto, then that function is invertible. We will discuss more on this later. So if f of f is a function of a to b, g is a function of b to c, be a 1 onto function. Both are 1 onto, so both inverse exist. Then g of f is also a 1 onto function, and is so if this is also an 1 onto function, then definitely its inverse is going to exist. And if its inverse exists, this is the property reversal law. In matrices also, we'll discuss this. But anyways, let's not go there. It happens everywhere. Like most of the cases, we use its existence reversal law. This is a composite function. Its inverse can be written as a composite function from F to G. Huh? F is changing place here. Okay. And
Yes, sir.
also one more thing is F of G of X is not equal to G of F of X. Okay. As here also we have seen G of F of X was this, and F of G of X is this. So they are both different, right? They are both different, right? F of G of X and G
Yes.
of,
Yes, sir.
so that's why we have written it. So let's now go back where we have left some topics. Invertible function. So as we were discussing earlier, that invertible is a function which is 1, 1 and on 2. Okay. Now let's discuss what is a function first. What is a function? Come on, tell me. What are the properties of a function? Considering these are the elements, these are its codomains. Yes, please speak. Please speak. What is a function? A function is a relation from domain to codomain such that every element in domain is getting mapped to unique element in codomain. है ना? There cannot be two output for a single input. Two inputs can have a single output. We were taken this example A, B, where A, C, B, M was a trick. So A being the set of children, B being the set of mothers. So one children cannot have two mothers, but one mother can have two children. So this case is possible as two children can have one mother. So two inputs can have same output, but no one input can have two outputs. So that was the case, right?
Yes.
But as we are discussing about invertible function, so for finding the inverse of function, we will simply do one thing is we will change, we will change the codomain and we'll change the domain to codomain. We'll shift places simply. Okay. So the domain has come on the different position. Wow. Okay, so you got the point that domain and codomain shifts the position and then the function becomes an inverse function. So now inverse function to get defined. Okay. Uh, these are the codomain and domain of, this is the domain of f of x. This is the codomain of f of x. Now they have become the domain of, as we are discussing about now, f inverse of x. So domain of what? F inverse of x. Now this is what? Codomain of f inverse of x, which was earlier domain of f of x. Now here, this invertible function to be function, this particular element should get mapped to one element, and this also to another element, and these two elements can have a single, these two elements can have a single output. But if two elements here are having single output, and we go back and discuss the function, because this was originally the domain of a function. This is originally the domain of codomain of a function. So here, what is happening? One input is having two output for f of x because they have just shifted places, right?
Yes, sir.
Yes. So that is the reason. That is the reason this case should not happen. This just should not happen. Okay. This just should not happen. Every element should get mapped to one and only element and every element in codomain and code domain should get mapped. Then only the function and the inverse of the function will exist. So if this is happening, so one is one input, one output, one input, one output. So this is one function. So the function has to be 1 1 for its inverse to exist. And also all the element of codomain of the all the element of codomain of f of x are now the element of domain of f of inverse x. So that's why they has to be get completely mapped. If they are getting completely mapped, now the codomain is equals to range. That's why the function is on to function. If there is any doubt, I'll repeat. Is there any?
No doubt, sir.
Okay. So this is the condition. That is why the function has to be 1 1 and on 2 so that its inverse exists. Simple. This is the condition for a function to becoming invertible, to become so that its inverse exists. Discuss, let f be a 1 1 onto function from a to b. This is the condition. I have discussed the y. Okay, let's now read further. Let y be an arbitrary element of P. Then f being onto there exists an element x belongs to x. There exists an element x in set A such that f of x is y. So and also f being 1 1, this x must be unique for each. It's like Guma Firake. They have talking about the same reason that the domain is a codomain also, and the codomain of f of x is a domain also. So the codomain must also be get mapped completely, and the domain must also be get mapped completely because it's a domain and it's at the codomain of someone else. That's why the function is on to, and we cannot map two elements to one output because if we inverse the cases, then it is equivalent to saying that one input is having two output, which is not the case in case of functions. That's why the function has to be 1 1. This is the reason. Clear?
Yes, sir.
So, for if the if function was existing from A to B, now the inverse function will be from B to A, such that f inverse of y suggests f inverse of y is equals to x, such that f of x is y. It's similar to saying if exposed. Okay. Um, it's similar to saying my God, it's not. If we are writing sine of x is equals to y, then what is x? Sine inverse of y, right? Right? Right or wrong? Are you there? Let me repeat. If f of x is y, then x may also be written as the inverse of the function y. Similarly, we have written this here. That's all. The above f inverse is called the inverse of function. A function f is invertible if and only if the function is 1 1 onto. I hope that's clear. Now let's discuss one example. Now we have to find out the inverse of this function from real number to real number. So for doing this, we have to check first whether the function is 1, 1 onto or no. Discussing about 1, 1 onto, we can simply see this is a linear equation. So 7 gets cancelled. 4 comma x1 minus x2 equals to 0. 4 cannot be 0, so x1 minus x2 is 0. So x1 is equals to x2. So it is 1, 1. 1, 1. Now let's check about on 2 or not. So it's a function from real number to real number, and for checking out 2, we can do one thing is that key will this be function where this function will be defined. Okay, so for domain, this function is unrestricted. It's mapping all the elements in real number. All the real numbers can be the input of it. It's not, if the function is like this, then for output being real, this cannot be 0. So that's when we have to restrict the domain. But it's not the case now. So the domain is unrestricted. Domain is set of real numbers. Now let's check of range. Now 4x minus 7 is also not restricted as x is real number. So 4x minus 7 can also, like if you multiply 4 by both sides, then 4 of real numbers, then that's like multiplying 4 by a set of real numbers. They are also real number, all. So 4 of x is also real number. If we subtract 7, if we subtract 4r minus 7, so they are also real numbers. So the range is also not restricted. The range is whole set of real numbers. So range is equals to codomain, which is here. So this is own to function as well. Okay, let's now check the inverse of the inverse function is defined by. Okay, so let's now find out the inverse of this function. So let f of x is equals to y, and we know x will be equals to f inverse of y. So let's find out the value of x here. So y is equals to 4x minus 7. Y plus 7 is equals to 4 of x. Y plus 7 divided by 4 is x. X is equals to f of inverse of y. So y plus 7 by 4 is equals to f inverse of y. This is an inverse function. We only care about f inverse. Right? The variable is just a letter. So let's replace the letter with x. X plus 7 by 4 should be our answer if the given inverse function is in terms of x. That's why we have conveniently changed the variable. So the answer should be B. Yes, it is the case here. I hope that's clear. If any doubt, you may ask. So function x, y, b2 and non-empty sets. F is a function, f of function of x into y. That's like x, the code domain, and y is the codomain. Written as f of x to y is a rule or a correspondence which connects every member, say x of x, to exactly one member, say y of x. Y is an element of set y, x is an element of set x. Discussion about code, domain and range. So set x is domain or definition or inputs of f, and y is called codomain. The set of f of x consisting of all images is called the range. Range is always a subset of codomain, or it may also happen range and codomain are equal. Then the function is codomain. Then the function is onto. Range is also set of outputs. Y is equals to f of x is not a function. Y is a function of x if there is an input for which we get more than one output. Y is f of x is not a function if there is an element in the set of x for which we do not have its image, for which we do not have its output corresponding element in set y. Okay. So let's now discuss the domain of the function. So first, let's understand what is domain deeply. So here is a deep definition of domain. Domain of a function is a set of all possible input values of x for which the function is defined. Domain of a function is set of all possible inputs Set of all possible inputs for which function is defined. Let us say, let us say function is defined from x set to real numbers, and function is 1 by x. Okay. Now all the output which are coming from f of x is the range. And now range is the subset of codomain. So the codomain here is real numbers. So it is the like superset. Real number is a superset for all the outputs of f of x. But if we take f of x as 0, so 1 by 0 is infinity, which is not in real number. Okay, this is not defined. That's why it's not a real number. So for that case, we are going to exclude 0 from the domain. And for all other values of x, the function is defined. There is no contradiction as such. And also, x cannot be imaginary number like iota. So for all real numbers, okay, for x, the x set, the domain, the x set is belonging to all real numbers, excluding 0 as an element. So this is our code domain to define the function as given. Any doubt? I hope no. Okay. So going back, coming to the question here. Now, the domain of function, where function is having its set, it's like defined to real numbers for set of real numbers. So for its output, for the f of x to be real, x square minus 4 has to be real. Okay. Now we know square root of negatives. Negative 1 is iota, which makes the number as imaginary, which is not real. So we have to avoid this particular situation where x square minus 4 is negative. So let's find out when x square minus 4 is negative. Okay. So this is what? X plus 2, x minus 2 less than 0. Mapping the mapping plus 2 and minus of 2, minus of 2 from here, plus 2 from here, and plus infinity to minus infinity, where we call method, the coefficient of all variables is positive. So this, the whole function is going to be positive here. This is going to be a negative positive. So now we require the values of x where the function is negative. So for x being minus 2 to plus 2, where minus 2 and plus 2 are excluded for all the values of x, in between minus 2 and plus 2, the function is assuming its negative value. So we have to ignore these values. So our domain, in our domain, how we will write our domain? Our function is defined when the function is this particular term is assuming positive value. Okay, positive or 0 value, like less than, it should not be less than 0. So we can take all real values of x excluding this particular period. So we can take all the values from minus 2 to minus infinity and plus 2 to plus infinity, minus 2 excluded, plus 2 excluded also. So the domain should be from minus infinity to minus 2, inclusion of plus 2 to plus infinity. So that should be, or this should be, or this should be our answer. Now, if we take x as 2, so the function is becoming 0, which is not a problem for us. Which is not a problem for us. So we can include minus and plus 2. Here we were discussing about these values which we have to exclude. So from the domain of real numbers, with this particular period, we have to exclude. It means if here minus 2 is not included, so we can include this particular minus 2 and plus 2 values in our domain. That's why square bracket is there. Second answer. Yes, it is correct. Okay. So shall we conclude the class now?